All right, guys, so yesterday we learned how to simplify square roots with numbers only. Today, what if there's also some variables in there? All right, so we're actually going to do it the same way. You're going to do it exactly how you did the numbers, and then we'll do the variables separately, but very similar. So for this one, let's just pretend it was just square root of 54. And let's do what we did yesterday. So you do the prime factors of 54. Okay, so 54, for example, could be 6 times 9, and then 6 could be 3 times 2 and stop, and 9 could be 3 times 3 and stop. Okay, those are all prime. And then if you see any doubles, if you see any identical pairs, so I see a double 3, I get to take that out. And then anything left over gets multiplied and stays inside. So 3 times 2 is 6. Okay, so that's what we did yesterday. But now we also have an extra piece. We have the square root of a squared. Okay, so I bet some of you could figure this out on your own, but here's how I do the a part. If it's a squared, I write it out 2 times. And then same thing, if I see an identical pair, I get to circle it and it comes out once. So one pair of A's comes out, and then there's no singles left, so this is the answer. 3a root 6. So a double 3 comes out as a 3, a double A comes out as an A. All right, let's try another one. So number 2. Again, let's just do the root 18 first and pretend it was like yesterday. So go ahead and do the prime factors of 18. 18 could be 9 times 2. Remember, you could do it different. 2 we get to stop, but then 9 is 3 times 3, and we get to stop. Okay, I see an identical pair of 3's, which means a 3 comes out, and there's a single 2 left inside. Okay, and I left some space for the B's. We have 4 B's. Okay, which means we have 2 pairs, which means we could pull 1 out from this one and 1 out from this one. So a B times another B is a B squared. And there's no singles, so they all come out. All right, let's keep going. Let's try 3. So number 3, get a new color here. All right, square root of 24. Go ahead and do that. 24 could be 6 times 4, but then 6 could be 3 times 2, and we stop because those are prime. And then 4 can keep going to 2 times 2, and we can stop because they're prime. Okay, do you guys see any identical pairs? I see a pair of 2's, which means a 2 comes out, and what's left inside is the single 3 times 2, which is 6. Okay, but now we have to do the c to the third power, so that's c times c times c. Okay, I see 1 pair and 1 single, which means 1 C comes out and 1 C stays in. So that's the answer for this one. If this isn't making sense, call me over. I'll clarify. And then lastly, number 4, let's do root 45. So 45 could be 9 times 5. 5 we get to stop because it's prime. And then 9 can be 3 times 3, and we can stop because they're prime. Okay, I see a pair of 3's, which means a 3 comes out, and a single 5 left inside. And now let's deal with our variable. Oh boy, there's 2 of them. Uh-oh. All right, let's see what we got. We got 6 x's. And we got 3 y's. Oh, all right, we can do this. How many double x's? How many pairs? 1, 2, we got 3 pairs, which means we can pull out an x3. And how many pairs of y's? Only 1 pair. So we could pull out 1 y, and then there's 1 single y left inside. That's your answer. Okay, so this is called simplifying with radicals. Nice job, guys.